Hi, my name is Wang Long Chen, and this is an HD task. And the objective of the task is to analyze the COVID-19 data and find meaningful relationship between the sentiment video title and the sentiment of its corresponding comments. The same apply for the viewer likes and duration, and I use correlation and regression analysis to find if there is any relationship between the three predictors and the response variable. The response variable is a comment sentiment. So like in the distinction test, Deacon has provided us a notebook to collect and clean the data first, and also yeah, they clean the data first. But one thing I noticed is that I have cleaned it. It is a text block library. It doesn't really give good results. So I use a model from Hugging Face that shows the probability of a sentence being positive, neutral, or negative. So I would be taking the label 2, which is the positive label. So I will take the probability of the positive. In this case, if the probability is closer to 0, meaning it's negative, closer to 1, meaning it's positive, and the middle is 0.5 is the threshold. And first I will need to confirm like Torch is using the GPU, so it's using CUDA, which is using the GPU. And also, here's a code I got from Hugging Face. So it's a pre-trained model, and I'm using the sentiment part. So if you look at here, so I take the first sample comment, and it will categorize the negative, and I will be taking the positive probability. And now I will apply that to the data frame. These first five columns, first five rows of the data frame, and here's the apply to the data frame. So for the analysis, before I go into any details, I want to compare the difference between the correlation and regression. So correlation hints a relationship between two variables via the strength and direction. We can see there's a statistical association by examining the correlation coefficient. Regression looks at the independent variables and dependent variable. It predicts whether a change in the predictors will affect the response variable. And this data, I load the df2 CSV, which is the applied sentiment score to get the positive probabilities. And this function is creating the calculating the Pearson and Spearman correlation and showing the scatter plot. And this part is just grouping all the data. So I group the calculating the average for each video. So for the video title assessment score with the comments, the like count and the duration with the comment as well. And as we can see here are our three scatter plots, and we can see that the video title assessment score has some sort of positive association relationship with the comment assessment score. The light count shows, well, it shows nothing, and the duration shows maybe a correlation. Perhaps we need to further investigate. And also we can see that most of the video title sentiment score and comment sentiment score have a low positive probabilities. This means that most of the sentiments are negative. Interesting. And now we will perform some regression analysis. So I will first merge the three grouped data into one. So here's the grouped data merged into one, and check for new value. So there's no value. So before we're doing the regression analysis, there's something we need to check. We need to check for the R square, which tells us the variability of the dependent variable. Can we explain the dependent variables? The probability of F statistics is it tests significant for the entire regression at alpha equals 0.05. If the p-value is smaller than that, it means that it's significant. Overall regression model is statistically significant. The p-value for coefficient t-test is an individual p-value compared to the with the response variable. So like last time, we can reject or accept the new hypothesis, and the probability of this thing of these two check if our residual are normally distributed or not. So there are three assumptions in regressions, which multi-collinearity, that is two or more independent variables are highly correlated, non-normality in residuals, that means that our residual is not normally distributed, and heteroscedasticity, which means that the residual is not constant across all levels of independence. So that's the three assumptions you need to check. So to perform, I'll be ignoring the multicollinearity because we only have three predictors. So first I will scale the data. I'll fit the data, the response variable, and the predictors, and here the output. So we can see that the R square is pretty low. It's 5.004. It's 5%, and so 5% of the total variance can be can be explained by the regression model is very low, but it's fine. So the probability of the aesthetic is smaller than 0.05, which indicates like a strong evidence that the independent variables have a significant effect on the dependent variable. But if we look at the individual p-value, only the video title sentiment score is significant with the comment sentiment score, and the other two, the duration, the light count, have no significant values to it. And so our p-value of these two things is smaller than 0.05, which reject so it said that our model is not normally distributed. And so this function is just plot the residual visit, the feeder plot, the normal QQ plot, scale location plot, and the residual visit, the leverage plot. And as you can see, our residual visit fitted plot, the points are condensed in the right side. We need to do more investigation. And the normal QQ plot, we can see that it's not normally distributed. So I will remove the outlier using the Cook's distance. So Cook distance is a summary of how much a regression model changes when the observation is removed. It's also take into account the leverage and the residue of each observation. So there might be some outlier here. And I got the code from the medium, and so I just removed the outlier and fit our model. So after removing the outlier, we see that our model is like the R square is 2.6%. Well, it is fine. And here's the plot. So I need to do more tests to check on the constant of the variance. So these two tests will do that. And as you can see, the two tests show that the p-value is more than 0.05, meaning that we can reject the null hypothesis, which is that the null hypothesis is the variant of the residual is content across all levels of independent variables. No, I mean we cannot reject that. So we accept that the variance of the residual is constant, meaning that that assumption is not violated, which is good. So only the residual normally distribution assumption is violated, and the possible reason for that assumption violation is that the majority of the amount of the negative sentiments in comments may be the culprit for the skewness in our distribution. And I will examine the video title sentiment score. So I isolate other predictors. So we can see that there's a positive relationship. So in conclusion, only the video title sentiment score has a significant effect and positive relationship with the comment sentiment score. So my assumption after the conclusion is that the positive relationship between the video title sentiment and the comment sentiment may indicate that the tone set by the title greatly affects the comments. What I mean by this, during the time of uncertainties, people tend to find positive things to uplift their mood. Also, during COVID-19 period, the majority of us is in a state of worry because we don't know much about this new virus and pandemic. For that reason, the video sentiment score, video title sentiment score, and the comment sentiment score are skewed toward the negative side. So some of the challenges and obstacles I faced during this task was the textbook library. It gives very inaccurate results, so I need to use a pre-trained model to sort of find the positive probabilities label and use that as an response variable. And also I have to understand what regression analysis is, so I have to watch many videos and analyze a lot.